Hello, AI enthusiast. Welcome to our YouTube series for building generative AI platforms, part 4. I'm Sposh and I'm excited to take you on a deep dive into the fascinating world of generative AI and building generative AI platforms. For the people who are watching this series for the first time, I would recommend you to please watch the first 3 parts to get a better understanding of what we are going to discuss in this particular section. For the people who have been watching us, just to give a brief overview of what we have discussed till now. In this particular series, we were trying to learn how we can architect a generative AI platforms from and starting from scratch to adding more and more components within each session of the series so that in the end we get a very good, very robust architecture for generative AI platforms that we have. In the first part of the series, we learned how to build a basic generative AI based platform in which the user or the user is giving a query to the model API or the LLM model, and the LLM model is processing that query to give a final response. Then in the second part, then in continuation, we learn how if we can improve the context construction of that particular query, how we can improve the outputs of the model. And in the context construction, we had a look over about how the RAG aspect of it can help, how the agent can help, and how query rewriting can help. In that particularly read for the we had two things. First is getting that context from the databases that we have, maybe chat history, vector databases, documents, tables. Then through agents or through engineering, we can have these vector search, running SQL queries, or doing a web search, which majorly may involve agents or tools. Then in the second session, the next session we talk about like the putting in proper guardrails into the place. And in that guardrails, we discuss about the input and output guardrails. Input guardrails were kept into the place so that no personal information might get into the model, which might scrutinize the confidential information. And the output guardrails so that it's safe, it doesn't reveal any identity of the company, and it has structured proper output as to what is intended. Then in the next session, and in that particular session, we also learned about the different scoring aspects of the outputs of LLM so that we provide the best output to our user. Then in the next session, we learn more about the model gateway and the routing, in which particularly for our platform or for our service, we might have multiple LLM calls, multiple services or tools built. And what a model gateway or router help us to do is to route the right query to the right set of services that we have built, which in turn would help us improve the quality of the results being faster, and at a lot of times it would help us implement those failback mechanism such that the overall architecture of the platforms that we have is much more robust as compared to the simple platforms that we might have built earlier. And now in this part 4 of the series, we are going to discuss about the cache or the caching approach that we can put into the place. And without further ado, let's deep dive into the caching aspect of generative AI platforms. So there are a couple of reasons why we are going to use cache, and one of the reasons is reducing latency. A lot of times, when when the different user or the same user is coding our application, a lot of times it happens the user is coding the same set of things that he has queried earlier, or one user might query what two different users might have used. So in that particular cases, we are going to use some sort of caching techniques based on the different use cases or technicalities involved. So one of the first thing is we would be using this prompt cache, and maybe before starting off this thing, maybe I would focus on this thing. What exactly caching and what kind of caching? So caching techniques can also be used during training, but it's more about we are going to discuss this thing from the perspective of deployment or the inference part. And some of the common techniques are the prompt caching, the exact caching, semantic caching. When when we are evaluating an inference library, it's helpful to understand what cache mechanism it supports. And one of the things which a lot of people who might be using transformers might have a good idea is the KV cache. That is for the attention mechanism, and it's basically a lot of times we have a lot whenever we are running these input text with the transformer models, it's doing a lot of calculations. And what KV cache help us to do is it stores in cache a lot of calculations that we have already done, and given the similar input, it starts from the place that it from the cache only, not from the scratch. Now coming on to the part is the first aspect is the prompt cache. And generally, a prompt cache it stores the overlapping segments for reuse such that we need to process those things only once. And a lot of times, an overlapping text segment that we use in our prompts is the system prompt. And a lot of times, if we have a system and if we are processing system prompt each and every time, it might add up those particular tokens in each and every aspect of the model API run that we have. So a lot of times we do define something as system prompt and we try to implement the prompt cache. And then with this thing, it might need to process the system prompt only once for the first query, and then it keeps on taking from the cache from the next time. And a lot of times what happens is if our system is a small, it's okay if our prompt is small, but once we keep on generating bigger and bigger, more and more, if you're trying to scale the services, for example, if we are generating one model, 1 million API calls, API calls today, and for 1,000 tokens, it's going to be, if we do rough calculations, it's going to be around 1 billion repetitive input tokens a day, which might cost a lot. And a lot of times in KV cache, the prompt cache size can be quite large. And because of that, it might require significant engineering effort. So it's a trade-off on both aspects, but generally it's recommended to put caching into place. And the second aspect of caching is the exec cache. And I would say exec cache, it's similar to how we develop the normal software engineering applications. It's more of like if you have the same sets of queries, same sets of things already been performed earlier, it's not a good idea to perform those things again without searching into our database or the cache that if we have already run the same query. So in short, it's the exact cache is more of like a matching or searching through in a cache if we have run those particular same queries, and if we have run those same queries, then from the cache we exactly gives out the same output. In case if we cannot find that thing in our cache, then in that particular sense, we run that particular query. And the exact cache, this could be implemented using in-memory storage for very fast retrieval. And a lot of times the in-memory storage is limited. So in that case, we can implement those things using Postgres, Redis, or different tiered storage to balance speed and the storage capacity. And a lot of times, having an eviction policy is crucial to manage the cache size and maintain performance. And common policies include LRUs, LFUs, FIFO approach. And how long a cache query can be depends on how likely this user is to be called again for the same sets of things. Now coming on to the final or the main sets of cache that might be a lot different is the semantic cache. And semantic cache is more of like it tries to, from a similar understanding of the word semantic, it's try to map out in the cache, map out queries which are almost similar. And it, it has its own pros and cons, and it works very well in a reliable way if we have mostly embedding model through which we can get almost similar queries for using the vector search. And if the similarity score of that particular query is greater than what we have set as a threshold, then we um, return those cache results. For example, if we just try to see the common approaches for the query, for each query, generates its embedding using an embedding model. It could be maybe an OpenAI or fast embedding. Then using the vector search to find the cache embedding closest to the current query. Let's say the similarity score for this is X. Now, the X that we have generated, if it's less than the similarity threshold we have set, the cache query is considered same as the current query, and then cache results are returned. If not, then the process is in then the process we have to process the current query and cache it together with its embedding and the results that we have. And this approach requires a vector databases because we are dealing with the embeddings of the queries. Uh, and compared to the other caching techniques, semantic cache's value is more doubtful because many of its components are prone to failure. But if it works for certain high quality embeddings, then I think uh, there is no comparison for this thing. It could work out very well, but a lot of times it's prone to failure, and we might need to restructure or re-engineer so that we have the right set of semantic cache. So now looking at to what our architecture of the system looks like now is for the user query that the user has given, we will first search in cache. If it's already present, we give the cache response. If it's not, we try to create a context construction. And in the context construction, since a lot of things might be used like system prompts or the data that we are getting from databases or some any of the other things, then we directly construct that thing with cache. If it's not, then we give it to the particular query. And if we have get that particular responses from the data for our query, at that particular point of time, we also store those things in a cache so that if the next time a similar query comes, we revert these information from here only. And then we go to the next step, the context construction, then guardrails, model routing, and then finally returning the response. So I think this, let's try to keep this video short because we were just explaining the concept of cache, and people who are from software engineering background might already have a good idea about what cache means and different ways we can put cache into place. So thank you everyone for sticking to the end of the video. And if you really like it, please don't forget to like, share, and subscribe. Please let us know any doubts in the comments. See you in the next session. Thank you.